So the question always is, how much of this stuff is anthropogenic? How much of it is natural cycles or natural causes? That's a question that everybody seems to be asking all the time. Well, the few things you can kind of look at, right? So, you know, the question is, so why is the earth warming in the first place? We know that earth is warming. Why is it warming? Well, it could be that there's more energy coming in. So it's because there's more energy input. If it's more energy input, what is that coming from? Does it mean that there's more, maybe more solar radiation? The sun is brighter, sun is stronger, something about the sun. Well, in the past, we did see that, or at least speculation, because when we had warming without any human input, we can attribute that to Earth rotation and the tilt and changes in that. So we did, in fact, have increased more solar radiation at that time. But the current warming can't be explained by solar radiation, because if that was the case, if there's more sun coming in, we would actually see more warming along areas where there's more sun, right? But we actually don't see that. We actually see more warming in areas that doesn't get as much sun, so that doesn't make sense. So that's why we can kind of almost rule this one out, that there's increase in energy input. Well, what's another reason why the earth could warm? Well, there's less energy output, so there's more energy basically staying in and not leaving. Well, what could account for that? It would mean that the heat loss is somehow being prevented. Well, it's the greenhouse gases will explain that, right? That's what greenhouse gases do, that it prevents infrared radiation from escaping into space by maintaining it in our atmosphere. So this seems to be more of a plausible explanation for the Earth warming, and everything points to greenhouse gases as the culprit, and then the greenhouse gases are caused by human activities. So, that's the information that we have. Scientists come up with these climate models, right, to try to predict what's going to happen. So based on the trend of CO2 increase and the fact that it hasn't quite slowed down so far, right? It's a very regular increase in CO2 increase. And so if that keeps going the way it is, what can we expect given what we've seen so far? And they input all this stuff in a computer, and the computer comes up with predictions. And these are some of the, basically what we see. If we have increase in CO2, what's going to happen to the temperature? This is the low increase in CO2. This is the high increase in CO2. So we have different projection depending on whether or not we can actually maybe curb some of the CO2 increase, or it's going to just be business as usual. And, we can see some significant increases. Again, a lot of the increases are happening in the Arctic and in the polar regions, and also in terrestrial system as well, compared to oceanic. But this is overall increase. I don't see, very little places that's not going to see an increase. Scientists have a little harder time predicting precipitation, because remember, climate is temperature and precipitation. We kind of know the temperature is going to increase, but how that's going to affect the precipitation patterns, that's going to be a little bit trickier. And the reason why it's tricky is because there's all this feedback system that's working. Some of them are negative, some of them are positive, some of them have limits, and so it kind of it switches over, and that makes it very, very difficult to predict anything. You should know about some of these positive and negative feedbacks. We talked about it before when we talked about positive and negative feedback, I think back in chapter 2 or something like that. And a lot of the examples that we use were climate change feedback. So these all look a little bit familiar to you. So let me just I'm going to post a whole bunch of them here. Right. Here's an example of a positive feedback loop. As you have warming, it's going to increase decomposition in the soil, because as you increase temperature, everything happens faster, including decomposition. As you have more decomposition, it's going to release more carbon dioxide. That's a greenhouse gas that's going to cause warming. So that's a positive feedback loop. Here's another positive feedback loop here. If you got warming, you're going to have permafrost in the Arctic melting. The permafrost, as it melts, it's going to melt and have lots of standing water, like boggy soils, right? these wet soils is going to create anoxic conditions, which causes methane production. Methane is a greenhouse gas, so therefore it's going to increase warming. By the way, the permafrost is also storing a lot of the methane in the soil as well. So as it defrosts, that's going to release all that methane, and that's going to cause warming, and that's another positive feedback loop. Warming and water vapor is related. As you increase warming, you're going to increase evaporation. If you increase evaporation, you're going to have more water vapor. Water vapor is a greenhouse gas, so it's going to cause warming, and it's going to keep going and going and going. Here's another feedback loop. As you increase warming, you're going to melt ice. Well, ice is very reflective, but if you don't have any more ice, you're gonna decrease albedo. Remember, albedo is the reflectivity of the surface. So if light is not reflecting, it's going to absorb the energy, and it gets converted to infrared radiation, and that's heat, and that's gonna warm the atmosphere. That's gonna cause more melting. That keeps going. That's another positive feedback loop. There's some negative feedback loops as well, right? And in a negative feedback loop, basically, there's an equalizing effect, I guess. So as you increase CO2 in the atmosphere, that's going to by the way, this is the most important one. As you increase carbon dioxide in the atmosphere, that's going to increase plant growth. When you have more plants growing, they're going to absorb more carbon dioxide to do photosynthesis, right? So if you increase more plant growth, because they're absorbing more carbon dioxide, that's going to decrease the amount of CO2 in the atmosphere. So that's going to have an opposite effect here. But so if you decrease CO2 in the atmosphere, that's going to decrease plant growth, because now they don't have enough carbon dioxide, and that's going to reduce the amount of CO2 being absorbed by the plants, and that's going to increase carbon dioxide. So because you have opposite effects happening in this cycle, it has a neutralizing effect on the CO2. So it prevents CO2 from getting too high, because as you increase CO2, you're going to have more plant growth. You can also have negative feedback loop with water as well. As you increase warming, that's going to increase evaporation. Increasing evaporation is going to lead to more formation of clouds, and clouds are light colors, so it's going to increase albedo, so more reflectivity, right? More reflectivity means less light getting to the surface. That's going to cause cooling. So again, opposite effects here. Cooling is going to decrease evaporation. If you decrease evaporation, then you're going to have less clouds, less albedo. That's going to cause warming. So this is a negative feedback loop as well. But both of these have to do with evaporation and water. So that's where, things get complicated. There are limitations to these feedback loops, right? Some of them are basically the same process, that having opposite effect. Right. So depending on how strong these things are, or which one's going to have a bigger impact, it's going to have an effect on, the overall impact. You also have things like this one, the soil, right? This is limited by how much carbon that's in the soil itself. So once the soil runs out of all the carbon, then it's not going to release the CO2 anymore. So that's going to put a stop to this one, right? This enhanced in plant growth thing, remember I said this is a very important process that's kind of almost helping regulate the CO2 in our atmosphere. Well, there are other things that limits plant growth. It's not just CO2. There's water availability and nutrients. In fact, we talked about how water is a limiting factor in a lot of these ecosystems, and the reason why deserts don't have as much plants is because there's lack of precipitation. And then also nutrients is a huge limiting factor, like, especially nitrogen for plants. So it's not CO2 that's limiting. So, those are other limits to these feedback loops. So the take-home message is that it's complicated. Nothing is simple. Okay, so these are the causes of climate change. What are some of the consequences? So let's talk about the consequences. There are environmental consequences, and there are consequences on living things. And all of these are very familiar to you already, because we've been talking about them about it as we went along, and you also just kind of know about them because, these are just things that's, almost common knowledge at this point, right? So here, consequences to the environment of climate change. Ice caps are melting. When you have ice caps melting, that opens up the Arctic. So remember that the entire, the Arctic is ice, is floating ice. So if that goes away, you just gonna have open ocean there. So you essentially taking away that little habitat that's there, and that's gonna affect a lot of things in the ecosystem of the Arctic. One good thing that could come out of it is it was going to open up navigation. So, instead of going around the ice, ships can go across the North Pole to get to the other side, which is it's gonna be a big benefit. There also might be a lot of oil discoveries because I think scientists already know that there's a lot of fossil fuels under the ice in the Arctic, but that's going to be more accessible once all that stuff melts. By the way, important thing to understand that melting of the polar ice cap does not cause sea level. Floating ice does not add more water when it melts. What does add water when it melts is land ice. So when land ice melts, like the ice that's on Greenland and on Antarctica, because these are land or continents, when these melt, it's going to go into the ocean, and that's going to cause sea level rise. Right. Also glaciers too. Glaciers, as they melt, they will also increase water in the oceans, and that will increase sea level as well. But more importantly, when glaciers melt, glaciers are a very important water source for people who live in these areas. It's a water storage. So as the glaciers increase in the winter in size, and then they melt in the warmer months, and that is a source of water. So if it melts too soon, the water comes down too soon, and then there isn't water when they need it. It's also aesthetically, these glaciers are beautiful places, and the fact that they're all disappearing is very sad. We talked about permafrost before in the Arctic. As they defrost, they do release methane, increases decomposition, increases carbon dioxide as well. But also, permafrost is called permafrost because it's permanently frozen. So when that starts to melt, that's going to destabilize the soil. The trees are actually toppling over because they can't stay up in some of these areas anymore. Although generally areas that have permafrost don't have too many trees. Buildings and things are built in these areas are toppling because the ground is no longer stable. It's also draining lakes. If there's a layer of frozen soil underneath and there's water above it, but now everything melts and everything just drains. So the lakes are disappearing as a result. Sea level rise from melting of the land ice. But also, there's something called thermal expansion. So this happens as ocean's water warms up. They increase in volume, right? Things get bigger as they get warmer. So it's not that it doesn't seem like much, the oceans expand, water expanding as it heats. But when you're talking about the entire ocean, and even a few, like fraction of a degree increase in temperature can cause significant increase in volume. So that causes sea level rise. And the consequences of all this sea level rise is that, these coastal cities, many cities are along the coast, and these small island nations are going to be extremely vulnerable to flooding, especially during storms. So that's going to be a big problem for these nations and cities that are in these areas. You're going to have heat waves. That's going to have lots of human health consequences. That's also going to impact energy use because we need to cool down, more air conditioning use. That's lots of electricity. Water use for agriculture. So that's going to increase irrigation if there are heat waves. And it's also probably going to have huge impacts on food production as we have more droughts and things like that. And just, changing of the climate affecting food production. Cold spells, we're probably going to see less and less cold spells in some areas. So I guess that could be a good thing. That will be fewer deaths. There will be fewer risks to crops. It's going to expand areas where you can grow food because it won't get as cold. You might need less energy for heating. So these are all the benefits of having less cold spells. But sometimes some areas, these cold spells are extremely important for managing pests. Some pests and weeds and insects gets wiped out when there's a cold spell, and that's one of the main ways in which some of these pest species are kept in check. It's these abiotic limiting factors, right? But if these cold spells are no longer there, then these pests continues to thrive throughout the year, and that could cause big problems in some of these areas. It's talking about some of these woolly allergid. I can't remember. I don't even know what this is. I think it's an insect. Yeah, invasive insect that's causing problems in these forests. Before it was kept in check by these cold winters, but now the winters aren't nearly as bad. They're persisting and causing greater problems. Cold spells or cold snaps could actually increase in some areas. And we saw this with this whole polar vortex. So we have sometimes we've been getting this really nasty winters or like really spells of cold snaps, right? This is actually consistent with climate change. Some politicians especially are saying, how could we have 20 degree below temperature, winter in Chicago, and how could this be climate change? There's no such thing as global warming. Well, it's actually pretty consistent with what we would expect from climate change. So polar vortex is nothing new. It's actually always there. And during the regular months, they're generally confined to the Arctic, because you have big, significant enough temperature change between the Arctic and the rest of the world, that you have this very strong jet stream that kind of maintains the vortex where it is, right? The greater the temperature difference between these areas, the stronger the jet stream that maintains it, and the cold stays where it is, and the warmer area is warmer. In the winter, as the temperature starts to dip in these areas, the temperature differences becomes less, and this jet stream becomes more wavier. And because of climate change and the Arctic is warming, the temperature difference between these areas are becoming even less. And with the weak difference in temperature, the jet stream is weaker. And when the jet stream is weaker, it may cause it to meander more. So this wavy jet stream pattern is due to the fact that the Arctic is warming. And when you have this wavy jet stream, you're going to have some areas where you're going to have this cold air that's moving south. And that's when we get into this, this cold snaps in the winter time, where it gets really, really cold, because we basically have the Arctic air coming all the way down. And you can have some situations where you can have it dipping so far below down here, even down in the Carolinas and things. And so you might have like below zero temperatures with here. I think this year we saw somewhere like in the Midwest in Chicago, like minus 30 degrees or something like that, right? At the same time, in Alaska, it was like balmy 50-degree weather on the same day. And that just goes to show you this very wavy jet stream pattern that's causing this, weird cold spells in some areas and warm in others, all consistent with climate change. All right, running out of time.